Today's lesson is a continuation of our last lesson on present value of an annuity, and it's a specific example of that called amortization. So amortization is using the present value of an annuity formula to calculate the payments that need to be made in order to pay back a loan along with the interest that would accumulate. The mort in the word means death. So when you say you're going to amortize a debt or loan, it literally means you're going to kill the debt. So you're trying to figure out the payments that it would take so that at the end you end up with zero. So we're going to use the present value formula to accomplish that. So here's the situation. Suppose that you borrow $5,000 from a bank to buy a car and agree to repay the loan in 36 equal monthly payments, including all the interest due. If the bank charges 1% per month on the unpaid balance, so that's 12% per year compounded monthly, how much should each payment be to retire the total debt, including the interest, for the 36 months? Okay, so here's a case where you're taking out a loan. You need to figure out how many or how much your payment should be for a certain number of equal payments, in this case 36 equal monthly payments. So in this case, you want to think of that $5,000 loan as the present value. This is the amount right now, and you're going to try to solve for the payment that you need in order to have a present value of $5,000. Okay? So we're going to use the present value of an annuity formula, and the $5,000 will go in for the present value. The payment is what we need to find. Now for the rest of this, in our parentheses we have 1 plus I, and they actually told us specifically in the problem that we were going to be using 1% for I because it was 12% compounded monthly. And since it's 36 equal monthly payments, we'll have a negative 36 as our exponent. And then on the bottom, we again use I, which is that 0.01. So when you are solving this, I would recommend that you figure out what this all is equal to first, and then take your 5,000 and divide by whatever that amount is. That should get you the payment isolated and tell you what the payment amount should be. So if you do that on a calculator, you can pause the video for a second to actually work that out if you want. But when you do that on a calculator, you should end up with an answer of approximately $166.07. So that's what your payment would be over the 36 months to retire both the $5,000 debt and whatever interest that debt is going to earn over that 3-year period. Now, one other question with regards to this. How much are you actually paying back in total? So if you take the $166.07 and you multiply that by the 36 total payments, then that means you're actually paying back $5,978.52. Okay, so you can see from this amount that your total is $978 more than what you borrowed. And so you're paying back the $5,000 you borrowed along with $978.52 in interest. So those are the kinds of things you need to keep in mind when you're taking out a loan, is just how much total interest are you going to have to pay back in addition to the actual amount that you borrowed. In this case, it would be almost $1,000 that you'd have to pay back, spreading your loan payments out over 3 years. But that's how you use the present value of an annuity formula to help you figure out how to amortize a loan, how to pay off a loan, and what those payments should be for a given number of equal payments. So keep that in mind, and in our next class we will build on this to look at some other types of problems where using amortization would be helpful. Until then, have a good evening. We'll see you next class.